To simplify this expression, the first thing I notice is that the index is different for the numerator and denominator. The index is a 3 for the numerator, and every square root has an index of 2. So what we're going to do instead is convert each of these to fractional exponent form. So to convert the third root of 4, 4 becomes your base, and then your index, which is a 3, becomes your denominator. And since 4 was to the first power, it would be 1 is your numerator. For the denominator, 2 becomes your base. Your index, which is a 2 for every square root, always becomes your denominator. And because it was 2 to the first power, it would be a 1 in the numerator. From here, we're going to convert each fraction so that they are alike. So we're going to find common denominators. So thirds and halves, I can convert both of those to 6. So multiply by 2 for the first fraction and multiply by 3 for the second fraction. So I have 2 6 and then 3 6. The next thing I'm going to do is I notice that I can create the same base here. I can make this base 2. 4 is the same thing as 2 squared. So this is 2 squared, and that was raised to the 2 6 power. And that's all over 2 to the 3 6. So I'm going to rewrite the numerator. I know in order to combine the exponents here, that's the power raised to a power rule, so you multiply. So if I multiply 2 and 2 6, I would get 4 6. So from here, all I have to do is apply the division rule. If they have the same base, the base is 2, all I have to do is subtract the exponents. 4 6 minus 3 6 is 1 6. And because the original expression was written in root form, we're going to write this answer in root form. So since the denominator is a 6, that's our index. We're taking the 6th root of 2 and raising it to the first power, which isn't going to change it. So I'm just going to leave it as the 6th root of 2.